Good morning, all. I welcome you all to the second day of this AICT ATAL 1 week faculty development program on finite element analysis for product design. Today, in the first session, uh, a speaker from Gujarat is going to talk to us on. I have requested him just now uh, on telephone, and he is joining in a minute's time. So just wait for a while until he joins. I'll introduce you. I request all the participants, please keep your microphone, and your cameras actually off as far as possible, so that the connectivity remains better. Dr. Kamlesh Joshi has given a request for joining, so I am asking him to join. So we will start shortly. Thank you. Good morning, Dr. Joshi.
Good morning, sir.
You can keep your camera on, sir, so that, while speaking also, you can keep the camera on, no problem.
Yes, sir. Yes, sir.
Good morning, Sadekar, sir.
Am I visible, sir?
Yes, you are visible.
Sound is clear?
Yeah, sound is also audible, no problem.
Okay. Thank you, sir.
Yes, thank you. So I'll, just introduce you to the speakers and then hand over the session to you, okay?
Okay, sir.
Yeah, good morning, dear participants. I am very happy to introduce to you today today's expert, Dr. Kamlesh Joshi. Dr. Kamlesh Joshi is working as assistant professor in Department of Mechanical Engineering, Institute of Infrastructure, Technology, Research and Management, Ahmedabad, Gujarat. Before joining IITRAM, the abbreviation of the name of the institute, commonly known, he was working as ad hoc faculty member in SVNIT Surat for some time. Dr. Joshi graduated from Government Engineering College, Bikaner, and then subsequently did his MTech from IIT Roorkee. Followed by that, he joined his doctoral research at IIT Bombay and successfully completed it. His areas of interest and research include non-conventional machining techniques, manufacturing and materials, and product design. With his brief introduction, I now hand over the session to Dr. Kamlesh Joshi and request him to begin his session. Thank you. Dr. Joshi, please.
Thank you, Dr. Sachin Naik, for allowing me to have a short talk in this FDP program. And so let me start my presentation. So my presentation is visible, sir? I hope my presentation is visible.
Yes, sir, it is visible. Fine. You can go ahead now.
Okay, sir. Thank you. So,
yeah.
So the topic of my presentation is the product design and overview. So these are the broad contents which I am going to discuss today. That is the first thing I will have is the product design and product development. So we'll see some basics because everyone knows a bit about product design and product development. So we'll go back to some basics. What are the basics which are required in product development, product design, how they are related. Then we'll discuss the modern product development process in new way and the reverse engineering way. The next part will be the different phases which product development process have, which is understanding the opportunity, developing a concept, and implementation of a concept. Then we will have references. So allow me to start my presentation. So product development. So let's get back to the basics. What is product development? Product development is entire set of activities which are required for a new concept to the market readiness. So we will have a new concept in our mind and we'll deliver it to the customer with his satisfaction. That is what are those entire set of activities are known as product development. What are those activities? Those activities are the product vision, what we want to make, what the effect of product will be in the market, that is the business case analysis, how will uh, market our product to the customer, that is the marketing effect, how will design the product, that will be the engineering design, how the product will be designed in an effective way with the help of design of manufacturing processes, and then validation of product design. So these are the broadly classified activities inside a product development. There is one more activity which is research and development. Some of the groups keep it inside product development as a part of product development, and some of the groups keep it outside the part of product development or do it at the beginning of product development. So research and development help in making product development fast. So product design is a set of technical activities. We have a set of technical activities, engineering activities, in product development, and set of non-technical activities. So the set of technical activities within the product development process is product design. It is aimed to meet marketing and business case vision and establishes solutions to the problem not solved before. Also, it provides solutions, new solutions to problems which have previously been solved. That is creating new solutions to the existing problems. So our product design, our product can be of original nature, but can be of redesign nature. So if it is an original nature and it is a succession market, then we'll say that it is a novel design. The novel design are those which are generally inventions, like laser photocopy. So previously there was different photocopiers. We have different methods to copy. When laser photocopy came and we can see that it disrupts the previous market. So whenever an original invention happens, it disrupts the previous market. However, there is a higher risk of original invention. If the invention does not work in the market, we don't know the mood of the customer, how will they adopt the technology, whether they will adopt the technology or not adopt the technology, what will be the pace with which they will adopt the technology. So there is a high risk associated with original design. Now we can look into the redesign. A redesign is something which is the things are already existing and the problems are already existing, the products are already existing, and we are improving the product in two ways, either in adaptive way, which is a novel way, or a variant way, which is just a modification of the previous product. If we are providing a new solution to the problem, like there are compact discs available, there were compact discs available in the market, and then this DVD came. So DVD were having the same size, same compactness, but they were having a larger amount of memory inside them. So we can see that DVD is an adaptive redesign, which is a profitable and with a reasonable risk. It may happen that the risk is not as high as the original invention, but it have some reasonable amount of risk. In variant design, we are not doing any novel invention. we are just doing the modification. We are changing the size, shape, the parts. We are resizing it in one way, like the newer versions of a car or the facelift of a car. So they are just resizing. They are just changing the size. They are making the vehicle larger or smaller. They are changing the bearing. They are changing the size or shape of the bearing. So they are just making a variation of it. The variation is not as profitable as original design or an adaptive design. It is less profitable. However, the inherent risk lying with the variant design is also low. So, therefore, the people used to do the variant redesign also. In product design, we will focus on engineering design. In engineering design is the design where the modeling to attempt the design task is done. This is done to make process quick, accurate, and cost effective. There are different type of engineering design. In the mechanical field, we'll do mechanical design. In electrical engineering field, we'll do electrical engineering design, architectural design, industrial design. So a general process, a general flow, how engineering design is done is given by Asimov's model, where we have some general information about a product and specific information about a product, then taken care of, and the design operation is performed. The output which comes is evaluated whether it is able to give us the satisfaction which we want from the product. If it is not, then again the specific information is provided. What are the needs which are still lagging in the product, and then again the product is refined for the need. So, in order to understand product design, we have to understand the product development process, because product design, as we have seen, is a part of product development process. So, there are some basic steps in product development process which may be technical, may not be technical, but a product designer, it is advised for a product designer to have a look or to be with product development process, with product development team, to understand what is going on from the first process to the step where we have the product designing starting. So we have modern product development process. The modern typical product development process has three steps. First is we have to understand the opportunity. What is the opportunity? What we are going to make, whether it will be adaptive design, redesign, and or original design. How to find that concept, what to look in the market, what the customer need. After understanding the opportunity, we have to develop a concept that how the product will look like, how it will be, how will it will satisfy the customers, and then the last step will be implementing a concept. So the broad uh, steps which are followed by these three process steps are these. So to develop a vision, to do market opportunity analysis, customer need analysis, and then competitive analysis, which is benchmarking. In the second step, we have to do functional modeling, product architecturing, and concept engineering. So all these steps we will look in a brief way through this presentation. And the last step, implementing a concept, will have embodiment engineering, where the physical shape of the product comes into the picture. This is a typical product development process, forward product development process. We can have the similar process steps for a reverse engineering process. So in a reverse engineering process, first, instead of looking for a new concept, we have to take a product, we have to initially select a product and reverse engineer a product. How the product works, what are the inherent properties of the product, and then we have to redesign the product. What are the things which this product lacks, what are the areas in which we can improve the product, and at last we'll implement a redesign. So there are these two strategies. If we have to develop a original product, we have to follow this strategy, first strategy, and if we have to redesign or reverse engineer or redesign a product, then we have to follow this strategy. So these are not hard-bound strategies. These are not hard lines that we have to follow these steps, but these are the steps which are documented by people who are popular in product development and product design field. So these are advised to follow during the product development process. The first step here, we have to understand the opportunity. So first we'll understand the opportunity. What is the opportunity? For understanding the opportunity, we have to do market analysis and customer need analysis. We will see market analysis. In market analysis, we have to ask what to develop. That is the first question which will come in mind. What we have to develop. So this is a canvas diagram of customer satisfaction, that if we want to develop something, at what stage it is currently in the market. Let's say we want to develop a mobile phone. What is the existing stage of the product in the market? So the canvas diagram discusses about the performance with the time. So advancement in performance with time of a product is understood with the help of canvas diagram. So let's say this is an old technology A. Initially, the technology there might be a time where the product technology started. Let's say the simple phone started. Then initially there was not a rapid growth in the product. The products were somewhere here. In the initial phase, you can see that products were somewhere here. These are the products. The advancement is not that much, and the performance in the product is not higher also. We have this stage. However, with the advancement of time, new competitors comes in the market, and the competition increases, and you can see a rapid growth in performance due to the more number of products in the market. So there are a lot of products in the market. So what happens? Refinement in current product happens. Refinement in current product happens. After some time, the technology gets old, and expansion and variation of products slow down. There is very hard to do more expansion in this technology. So this technology advancement follows an S curve. We have to find at which position our current product is there, where it is at this phase, or this phase. Sometimes what happens when the product is at this phase, where it is a limit, sometimes new technology may come in the market and it will disrupt this market fully. So this will be a disruption of this market. This point, our new technology is coming in the market. This is the point where the new technology has come, and then the new technology, let's say, these were for the general phones, and this is for the Android phones. This follows the Android phone technology. So currently we are here. There are a lot of technological products in the market which are following the Android technology, and it has destroyed the previous mobile phone technology. And it will reach its top somewhere, and then a new technology will come, and it will also disrupt this current technology. So we can classify the technologies in three stages. Stages one, the technology is in stage one, then it is a very good step, very good stage. We can go into the market, do some refinement, and then improve the product and deliver our product. If it is in stage two, then the competition is very high. However, the chances of getting success is also moderate in this. So moderate chances of success are here. But if a product is in the stage third, then it is very difficult to do improvement in the product at this stage, and also it is very difficult to do a new concept, to, to form a new concept which will destroy the current state of the product and create a new S curve to follow. So if we are looking for a new concept to come into the picture which will destroy the old technology, the risk of getting failure is very high. But if the concept success, the chances of the 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 cost, the profit from that will be very high. So we have to see at which state the product is there, and then will to understand the opportunity in the market based on the current state of the product in the S curve. So S curve, for example, the filament based bulbs were there. They were having their own S curve, and then the CFL came into the picture, and the CFL completely destroyed the filament-based curve bulbs and their market, and then it followed its own S curve, and now these new technologies are coming. So this is what we want to understand. There are exceptions of the S curve. Every product follows its S curve. There are some exceptions like the Moore's law. We'll discuss Moore's law and changing trade law. If the government changes the trade law and it opens the market to the foreign investors, the foreign companies, then foreign technology will come into the market. And what will happen that the S curve will not follow its path, and different S curve will come. So this is the limitation of S curve. If some trade law changes, the government policy changes, then our product will not follow the S curve. Another one is Moore's law. So what is Moore's law? Moore's law tells that the number of ICs, the number of transistors on a unit surface area of IC get doubled in every 2 years or 18 months. So what happens, if you can see from starting from 1900s when the IC technology started, it is not following any S curve, it is just following a straight path, and it is keeping on increasing. Until now, it is just following this straight path. It is not followed the S curve. However, if we can see, we can divide this straight path in the number of small S curves, because electronics industry is changing at very fast rate. So what is happening is that this line is following too many S curves, but they are not very big. They are very small S curves. The size of the S curve depends upon the rapid growth in the technology, and these small S curves are making a line. So there may be a point where the incoming 2 to 5 years, where the Moore's law will stop, the transistors will not follow the Moore's law. So that may be a chance. A customer need analysis. So we need to know what a customer needs. So we have this diagram, which is known as Skinner's diagram of customer satisfaction. Let's suppose there is a function which is delighting a customer. A function is there, let's say the safety feature in a car. So when a function is fully implemented, we'll say that the customer is happy, and the function is absent, we'll say the customer is not happy. So the horizontal line represents in the positive x direction the implementation of the function. Let's say the safety feature in a car, like anti-lock braking system or EBS ABD. And the negative axis represents the absence of that feature. There is an x-axis. X-axis shows the delightment of the customer, and the minus y-axis shows the disgusting of the customer. So we have a common expected curve like this. If the product is absent, our customer will be disgusted, and the performance or product performance is fully implemented, the customer will be delighted. So this is the expected performance curve of a uh, of a product or a feature in the product. If we are providing something new in the product which customer is not expected, then the customer will be delighted. And if the feature which the customer thinks that this is the general feature, it should be in the product, and if the feature is absent in the product, then the customer will be disgusted. So this is the curve which is known as delighted curve. This, when we are in this region above this curve, the customer is generally delighted, and when we are at this curve, which is the disgusted curve, the customer is generally disgusted, and the customer is not happy. And if the product is there, that this is the general expected performance curve. Like, when our product performance on this line, the customer is neither delighted nor disgusted. So what happens that we have to know what customer need, and those based on that we have to provide some additional features in the product which will delight the customer. However, the problem with this thing is that after a certain time, the customer thinks that the feature which we have introduced as a new feature, as a feature which will delight the customer, that feature the customer after some time customer think as a basic feature, and if the feature is also available, customer after some time customer will not be delighted. He or she will be expecting that feature, so they will not neither be delighted nor be disgusted with the feature. With the time, we have to keep on increasing the features in a product to delight a customer. That is the basic problem with the customer needs. So what are different type of customer needs? We have to first understand what are the different type of customer needs, what are the needs which delights the customer, what are the needs, what are the missing needs in the product which disgust the customer. Based on that, there can be different type of needs. Direct needs, if you ask a customer about uh, uh, a feature in a washing machine, you can say that the washing machine should be like that, that it can be easily transferred from one hole to the washing area. So these are directly needs. So we need not to ask a customer, we need not to ask a lot of questions a customer to get these needs. There are some needs which are latent needs. Latent needs are those needs which customer need, but he will not tell directly. We have to ask lot of questions with time so that the customer will understand, and then he will tell that these are the needs. Latent needs are those needs which help in delighting the customers. These are those needs which help in delighting the customer, because customer does not expect these needs. So these are unexpected. Direct needs are something which customer always expects. Then there are constant needs, variable needs, general needs which are required by all age group, all gender group, irrespective of the age, irrespective of the gender, the needs are there. And there are niche needs where only a certain small group of people need those needs. They are not highly required needs by general population, like a feature in a music system, the highly highly good music system in a car, it is not required by a lot of customers, but it will be requirement of a niche need. So we have to classify different needs. What are the needs which are expected by a general customer, and what are the needs which will delight the customers? What are the needs which will our product needs. In order to gather the needs, we have different strategies. We can take customer interviews, we can fill questionnaires, we can have focus groups, we can interview the customer in focus groups, and we can be the customer, we can buy the product, use the product, and we can understand the product. What are the features which the product is missing? How can we improve the product? So these are the various methods to gather customer needs. Now, the second thing is benchmarking. Benchmarking is measurement of performance of our product against a product which is best in the industry. So we are comparing the product with the best in the industry, and we want to know where our product lies as compared to the product which is best in the industry. Why we want to do that? Because Chinese general Sun Tzu said once that to know your enemy to know yourself, because in 100 battles you will never perish. So if you want to be best in the market, if we want we want our product to be best in the market, we have to do benchmarking. And benchmarking is not a step which is only required during the initial phase of the product development. After our product is launched in the market, we have to continuously do the benchmarking to keep our product in line with the best in the class, best in the industry. So how to do benchmarking? Benchmarking we can do, we can follow the several steps here. We can form a list of design issues. What are the design issues which we get from the customer needs? Customer need is a great source to get the design issues. Then we have to form a list of competitive products. What are the products available in the market which are competitive? Then we have to tear down multiple products in the class. So this is basically reverse engineering technique. We have to tear down multiple products in the market. Then we have to benchmark by function. What is function? We'll see. Not by component. We'll look at this step. What does we mean by the benchmarking by function and not by component? And then at last, we have to establish best in class competitors by function. So, what are functions? A function is a clear and reproducible relationship between input and output of a product. Okay. So, if we have a nail cutter, the function of a nail cutter is to clip nails. So, this is a function. Clipping of nails is a function. We have clearly defined the input and output relationship between the product performance. Play music is a function of a music system. Make copies is a function of a photocopier. So the general construction of a function is in this form. We will have an active verb and a noun. So a combination of active verb and noun makes a function. So this is a general black box model to show the function of a product, and then in the product there can be various subsystems. For those subsystems we'll have the subfunctions. So we have energy as input, material as input, and information as input, and we'll get the energy as output, material as output, and information as output. So let's see an example of function for a fingernail clipper. So in the black box model, we have defined that the function of a fingernail clipper is to clip nails. So this is the main function. Now what are the inputs here? So this here we have inputs, we have output. So the input, the energy input is the hand motion. The hand motion which we have is the input. The material is the fingernail or nails are the input material. And the information is that there are long nails, uneven nails, nails with debris inside them, and then we'll have some output information. The output information is that the energy is the sound energy, the kinetic energy of the nails which are getting clipped in debris, and the nail particles which are coming out of the process, and the information is that the nails with good appearance. This is how you can define a black bottle of the black box model of a product using the help of function. This is very important in the tear down process and in benchmarking process. When we do tear down, we'll tear down a product and we'll write the functions of various subproducts of a product. What will it help? We can arrange, we can have the information, what are the various parts, or what are the various components which perform certain functions, and we can arrange them in a certain way which helps other people to understand, and they need not to do again the whole process of the tear downing, the benchmarking to understand the component. So in order to do these processes, tear down, benchmarking, the functional modeling is required. This is an example overview of a functional modeling. We are using an example of hair dryer. So the black box model of hair dye is this one. We have a function which says that the function of the product is to dry hair. The input is the hot air, the energy is electrical energy, and the information is that it is a user control. We can control the speed of the air, we can control the location where the air must go. The output is the air, thermal energy, and information is dried hair. This is an information. Dried hair is an information. So this is what total black box models look like. Then we can reverse engineer, we can tear down the product, we can look into the several parts, several mechanisms inside the product, and we can have various sub-functions. So these are various sub-functions, sub-function 1, sub-function 2, sub-function 3. So this is the mechanism which is taking care of the air. So it is taking air as input. It will import air, guide air, export air through the outside veins. So this is the flow of the air through the product. Then we have another channel which is the electrical system of the product, how we are giving the input electrical energy, what are the motors, what are the actuators, how it is converting the electrical energy to the thermal energy, how it is cooling the heating the air, how the energy is distributed, and then it is guided, and the user input. So these three inputs are explained through different mechanisms. So we have an overall idea of a product, how the hair dryer is working using a functional structure of the hair dryer. So this is how the information will be quite useful for the people who are using who want to know about the product, with the people in the other people in the design development team, who want to know about the product but they have not done the reverse engineering or they don't know about the product. This information is quite useful. So after understanding the process of functional modeling, we'll understand the process of product tear down. So we all know the product tear down is something where we have to open the product to understand what is lying inside the product. We have to uncover the technology and architecture, what technology the product is using, what is the architecture of the assemblies inside it. We have to uncover the working principle of the product. Also, the important part of product tear down is to uncover the cost of the product. What is the cost of the product? To uncover the cost of the product, we have to do tear down. What are the materials to which the product is made? What is the cost of the raw material? What is the cost of the assembly? This will help us in uncovering the cost of the product. There are different strategies to do the product tear down. One famous strategy is subtract and operate procedure. Another one is force flow diagram. So we'll look at the SOP method, which is the subtract and operate procedure. What we have to do in subtract and operate procedure is we have to take the product. We will To do this, we have to have the different devices and different measuring devices, different devices which will help us in opening, unlocking the system, like the screwdrivers and measuring devices. Like if we want to measure the current through a product, then we should have a multimeter. So these devices and instruments we should first keep with us, and then we should start the product tear down process. So first, we have to disassemble any component from the assembly. We'll disassemble one component from the assembly. After disassembling the component from the assembly, we'll operate the product through its full range. We'll operate the product. Now we'll analyze the effect. So, what is the effect of removing one particular component from the product? This will help us in reducing the sub-function of the missing component. So we have removed one component. We operated the product to its full range. Now we can see the effect. This effect will help us in finding the sub-function of the missing component. Then we will replace the component to its original position, and then we'll take another subcomponent of the assembly, we'll remove the component, and then we'll do the procedure for all the components. So this is what we mean by replace the component and repeat the procedure for n times. This we can understand with the help of this diagram. So this is an assembly which converts the rotary motion of this arm. We have this arm which is having a rotary motion, and converts into and fro oscillation of this arm. So this is a top plate. This is a top plate, and there are some slots in the top plate. The diagram is not that much clear from the book, so let me draw it. These are the slots. In these slots, these are two pins. This is pin number 1. So let's say this is pin number 1. This is pin number 2. So this is rear side pin. This is front side pin. They will get inside to this slot. So when this part will move, it will help in moving this main shaft. With this shaft, because this shaft is attached with this pin will move, and when these pins will go inside this rotary arm, the arm will rotate to certain angle. We have to apply the subtract and operate procedure on this product. So let's start. Let's say we'll remove the first part. This is part number 1. This is part number 2. Part number 3. Like this, we can number the various components of the assembly, and then we'll remove the assembly and we'll operate the procedure. So we can remove the first part, and then we'll rotate. So you can see that if we are rotating, we are not able to, if it is input side, we are not able to provide any input to the assembly, so nothing will happen. So we can reduce the sub-function of this part is to provide rotary input to the system. Similarly, we can replace the pins. If we are replacing the front rotary pin, and then we are operating the assembly through its full range, nothing will happen, because there we are having additional pin here. Okay. So what we deduce from here, that the pin is a redundant pin. We don't need pin is a redundant part, and we don't need two pins. At this position, only one pin is enough to transfer the motion from top plate to the rotary shaft. Likewise, here also we have two pins which are transferring the motion from the rotary shaft, this rotary shaft, to this rotary arm. If we replace any one pin, then there also it won't affect the function of the product. At last, we can see this horizontal pin. If we are replacing the horizontal pin, this horizontal pin is for safety feature, so that the component will not come out of the assembly. If it is moving in this side, it will not come out of the assembly. The rotary arm will not come out of the assembly. However, you can see that if we remove the rotary pin also, the system will not come out of the assembly, because there are already these two pins which are taking care of this thing. So you can see that this horizontal arm pin is also a redundant part. So whatever the redundant parts are there, we can remove the redundant part. That's why how it will reduce the weight of the product. It will reduce the cost of the product. Okay, so this will help us in the substrate and operate procedure will help us in uncovering the sub functions of the various parts, getting the functional modeling of the part, and redesigning the part, help in redesigning part. If we want to redesign the part, if we want to remove this assembly, what we can do? We can just change the rotary arm from the back side. So if we can redesign it in such a way that it has a narrow opening which have a width which is smaller than the diameter of this rotary shaft, then the rotary shaft will automatically not come out of the shaft. So we can redesign the component to do. So this is how a product tear down process is done, and then you can have an SOP of the worksheet here. So we are removing top plate, and we'll see what is the function. So we deduce the function. The effect is that no torque transfer. Similarly, we can remove the front rotary pin. You can see that if front rotary pin is removed, there is no effect on the sub function, so it is a redundant part. We can deduce the sub function of the product. So this is how. This is just a small example how the substrate and process procedures operates. Similarly, we can have the force flow diagrams, which we are not discussing here due to time constraint. So then the benchmarking by function. We have to benchmark by function. We need not to benchmark by component. So any component in one product may not be functionally equivalent to a similar component in another product. For example, let's say this is one electrical kettle to heat the water. So if we are removing the cover lid of this kettle, and we are trying to deduce the functionality of this kettle, if we are saying the functionality or function, one kettle can have the function to just cover another product can have a function which to cover and cover kettle plus with power, because it can have a power switch at the top of lid. Here we can see the power lid is not at the top of lid, it is at the side. But there can be a product which is having a power lid over the top of it. So the functionality of the product, the component will change. Therefore, we have to benchmark the product by functions. What a component is doing in the form of functions and not by components. So this is the problem with the component strategy. So we have to do benchmarking by functions. Then at last we have to establish best-in-class competitors by functions. There can be two strategies in the best-in-class. One can be the highest performing solution in the term of product, any product which is highest performing. That can be one best-in-class competitor. Another product which is the least expensive solution. So we can use different product performances to get the best in class solution in the terms of best performance, in the terms of cheapest solution, and this will help us in benchmarking of a product as well as the benchmarking of the company. We'll again look the procedure shown here with the help of one example. So let's say we want to benchmark a coffee mill. So this is an example of coffee mills. The company which producing coffee mills is Brooks Mill. First step is to form a list of design issues. Though list of design issues are continually revised and updated, and in the list of design issues are obtained, the main source for these design issues is customer need. Let's say the design issues are fiber of the meal, the noise level in the meal, the size of the meal, the grind time of the meal. Then we have to find the list of competitive or related products of the group. So the reason where the Brooks Mill is there are other competitors like John, Molinex, Walton Bosch. So they have they have searched for the competitive product. Then they will do the information search through various sources about the location of the manufacturers, location of the companies, what are the customer groups, what are the market shares. This will provide a list of successful products in the market along with the design key issues. What are the issues, key design issues? What are the key design issues for which we have to tear down the product? Now we have the key design issues to tear down, so we can take multiple products from various companies, and this is for detail. This example is taken from the book, reference 1 of this slide. So in detail, you can go to the book, Kevin and Otto. So we have different design issues. We have different products. Products can be taken off, open up the product and search for the design issues using the benchmarking process, and then we can benchmark by function and provide best performing solution and least expensive solution, which will help us in finding the best product in the market and best company in the market. So this is an example. So all these things were the phase 1 of what we now we have already understood the phase 1 of the process, that is the understanding the opportunity. The second phase of a design product development is to develop a concept. So we have already understood the opportunity. Now we have to create several ideas and concepts to generate to convert the product into a final form. So a concept generation, we have some issues, we have the knowledge of the customer need, we have a target product, we want to make a product, we have some customer needs, what are the customer needs. Now what should be the strategy to develop the product which will fulfill the customer needs. So we have to use different strategies, and those strategies will make us help in generating the concepts, various concepts for the product. So there should be at least 3 design alternatives, because at this stage we are not looking into the technical feasibility of the solution. So sometimes if we are generating a solution to a concept, then in the design stage the solution may fail because it may be not technically feasible. So we should have at least 3, and we can have up to 5 to 10 design alternatives for the embodiment. And all these alternatives should be well documented using sketches and descriptions. Here, all the possibilities are considered without judgment. So, various concept generation strategies are that we have to study and review existing designs, we have customer needs, an idea about the product from the previous step, because we have done the benchmarking and analyze the market. Now we have to provide a solution, we have to generate a concept, we have to study and review existing designs. And the study and review is required because the concept generation is a creative phase of the product development, and creativity cannot occur in vacuum of knowledge. So we need to keep on doing the analysis time by time to keep us updated. And then illustration and drawing are required to reveal the informations and limitations of the ideas which we are trying to develop. And then we can use different technologies like brainstorming, 65 method, morphological analysis to create the concept, to generate the concept. We'll go in brief about these technologies, traditional brainstorming. So the brainstorming technique was popularized by Alex F. Osborne in his book Applied Imagination in the year 1967. So we have a problem here, and we have to get the solution of the problem. The rules during the brainstorming is that no one should be the judging ideas of other people. So we can sit in a group, and it is an oral method. So the people can give their solutions to the problem which is already there, and there is a moderator who will keep account of what are the ideas which people are giving, and they can discuss about those ideas. So the free thinking is there. The rule during brainstorming is there, no judgment should be there about the ideas of the other people. Free thinking should be there. Big numbers. So we want ideas from the people in big numbers, so that a lot of people can give their ideas and we can discuss over the ideas. The group size should be sizable, so generally 6 to 10 people can be there in the brainstorming. Then we should define a problem. Already we should clearly define a problem and give to the people that this is the problem and we have to discuss about it. And the people will be given ample time to react, to give their ideas, and we have to record the ideas in the form of writings, drawings. There are some rules during the brainstorming. Everything should be captured during the brainstorming. There should be active participation from the participants, and everyone should be asking the clarifying questions about the ideas of any participant. However, there are also some don'ts during brainstorming. We should not reject or evaluate any idea during the brainstorming stage. There should not be forced participation during this stage. We should not ask anyone to give his idea if he is not ready to think and ready to deliver his idea. And we should not ask the question to judge. We should not judge anyone if you are giving less technically feasible solution. However, the problem with brainstorming is that it is dominated by a small number of team members, which speaks a lot and relies on oral means. So it relies on oral means, so there is a lot of time there may be information which is not properly written and this can vanish while going to other phase. So to overcome this problem, there is one more technique, which is 635 technique, given by Brent Rosberg in 1960. So what happens in this technique is that there is no oral mean of communication. There will be a group of people. So the name only explains the process. There are 6 people. They have to generate 3 ideas in 5 minutes on some sheet of paper or on some sketchboard, whiteboard, blackboard, anywhere. So this is a time-bound thing, and there is no need of any moderator. There is a problem defined. Everyone is asked to provide 3 solutions in 5 minutes. So let's understand this problem with the help of this example. So we want to develop a lightweight fingernail clipper. There are several people in the group. So we have a group of 6 people. The members' names are given in the first column, and the sheet contains 3 more columns, which is the idea 1, idea 2, and idea 3. Now we have to give the sheet to the first member, say Rahul, and he will write down his idea in the sheet of the paper. That the fingernail clipper should have a plastic body. It can be used as a bottle opener. It should be small in size. Then the sheet will be passed to the next member named Jay. Jay can have its idea like the key should have a keychain. The fingernail clipper can be made as a keychain. We can use this material, carbon fiber, as a body, and we can attach a nail filer to the original product. So they can have different ideas. Everyone then sheet will pass to the next member. He will write down his 3 ideas in the next member. Similarly, the sheet will rotate through all the members, and we'll have a bunch of ideas at the time during this short period of time. So, so in half an hour duration, we can have these many ideas, 18 ideas. So if we can repeat the process, we can provide new sheet in the to the new batch. We can have multiple ideas generated through this method. The problem with this method is that it is there is no oral mean of communication between the participants. So there are some solutions which will definitely come when we are discussing the problem orally. Um, those solutions will not come into picture when we use 65 method for the concept generation. There is another method which is a morphological analysis. Sorry, in morphological analysis, this is this can be considered a similar approach with 635 method. However, in this method, uh, if we take a product, we have to break down the product into several parts, and then we have to list all the ideas, and then we have to look for the unusual combinations. So the problem is blasted into independent variables, like what are the different parameters in the product, what are the features of the product, what are the methods with which we can make the product, what are the parts and sub-assemblies which are required in the product. Let's say this example, I have taken this example from this link, the link is given. So we have a night lamp, and the problem is to develop an aesthetic looking night lamp. So we can break up the object into several parts. Let's say this is the top part, which is the cover part of the night lamp. The source of the light is one of the part. The pillar of the light is one of the part. The base of the light is one of the part. Then we can write it in a sheet all the different parts and what things, what materials, what methods we can use to make this particular part. So one participant will give the idea that The pillar can be made of metallic material, the cover can be cotton cloth, the light source can be light bulb. Another member can say that the pillar can be a fiber type, cover cell can be a paper. So these are the different ideas from different people. Now what we have to do, we have to look for the unusual solutions. What are the unusual solutions here? So let's say we take one idea from one people, then another idea, and then another idea. Now this is an unusual solution. And then we can think of making a design of the lamp using this unusual solution. So these are some techniques which are used to create different products. So one example of this technique is this night lamp. It is developed by Philip Starr, who is a famous French architect and designer. So this is how the his idea is there. You can go to his website and look at the various products of him. So this is where you see. However, there are a lot of different ideas. So there are structured decision-making methods required to check the technical feasibility and define the technical decision-making. The effective decision-making techniques are required to avoid not considering new ideas, because there is a problem with the developers that they are not ready to accept new ideas because those ideas are foreign to them. This causes a market failure to the product. Another problem is that another effective decision making technique is that strategy is that we have to fully consider different ramifications, effects of a decision. If all the customer requirements are not considered in the idea, then the product may lead to market failure. And if the product is not analyzed for the safety, then it can lead to accidents, hazards. So while making the decision, while creating the ideas, the next step is to see whether we are considering new ideas or not, whether the idea contains all the customer requirement, fulfills all the customer requirement, and the product is safe in for usage or not. So we have to analyze the product for the safety. So you can see that initially we have a bunch of problems. We have a problem. The problem can result in various ideas during idea generation. Then we have to refine those ideas into some useful ideas. When we are discussing about these useful ideas, some more concepts will be generated during concept development process, and more ideas will flow to the product development team. Again, we have to refine those ideas, and while making the final product or final decision or concept is known as concept embodiment. Some more ideas can come into picture, and at last we'll have a final product. This is the initial idea. So to refine these ideas, to refine the ideas, we should use some structured decision making methods to get the ideas which are profitable and to remove the ideas which are not good. So in order to do that, we have to consider something which is known as criteria, which will come from customer need. and alternatives, which will come from brainstorming generation phase. So, what are the criteria for which we want to design a product? Whether the criteria is about the cost or a development risk, technical difficulty. So all the criteria should be marked. What are the alternatives which are understood from the concept generation phase? We have to decide the alternatives. Then ranking will be given to the ideas and alternatives. Ideas, the alternatives will be evaluated for the criteria, and the negatives will be removed. So negatives are the poorly rated alternatives, and we have to remove the alternatives. So this thing can be understood with an method, which is the Pew concept selection method. So this method was given by Stuart Pew in 1990. So let's say we want to select a better light source. We have some alternatives. We have a incandescent bulb. We have CFL, compact fluorescent lamp. We have LED and halogen light. Which one is a better light source? Which one is a better light source? However, what does we mean by better? What is better? So in order to define better, we have some criteria, some customer needs. Customer needs says that the light output should be high, the power output should be high, life of the product should be high, the cost of the product should be low, the size should be also small. So these are the criteria. We want our light which can give a high light output, high power, life should be higher, the unit cost should be lower, the size should be lower. So we can add more criteria like the electrical consumption should be lower. So these are the customer needs, and we have alternatives. Four alternatives we have to choose. Instead of these alternatives, we can have design alternatives from the idea. So, but in order to explain the procedure, I am taking these alternatives. So we have four alternatives, some criteria: lightweight, power, life, unit cost, and size. We have IV, CFL, LED, and halogen light, and we have to decide that which one we can select or which one we should remove, or what is the better solution of selecting a better light source. We can weight the idea from 1 to 5 scale or 1 to 10 scale. The light output is given a higher weightage, power is also given high weightage, the size is given a small weightage. So the customer are not bothered about the size of the. So these weightage are also decided from the customer needs and design team. Then we have to select a reference. Anything is a reference, which can be our current product, which can be the best product in the market, or any product on which the design and development is has come up to a conclusion. So this is the product, and we have to compare the other products which with the datum. So this is our datum. So we have considered IB as datum because this is our, let's say this is the current product, and we want to compare the performance of these three products uh, with reference to IB. S is the performance, means same. S will be the same. Plus will be better, and minus will be worse. So if we are considering the light output, you can see that all have the same light output. And if we consider the power, then this is the better power, this is better power, this is minus, means it is worse in performance. Life wise, all are good than the datum. So we have provided pluses. Unit cost, this is the cheapest, so we have provided minuses. The size, everyone is better in size, let's say, so we'll provide pluses. Okay, so this is the, now we have to find how many total pluses are there, the summation of the pluses. So this one plus is there, we have to multiply it with its weight. This plus is there, we have to multiply the weight, and this plus is there, so we have to multiply the weight. So 4 plus 4 plus 1, that is 9. Similarly, we will calculate minuses and total same. This is for CFL. We will do the same calculation for all the products, and then we'll count the overall plus and minus. How many pluses are there? How many minuses are there? So 9 minus 3 will give 6. 9 minus 3 again will give 6, and 5 minus 7 will give minus 2. So this is negative. So we have to attack the negative. The halogen light is performing worse, bad when compared to IB. So what we have to do, we have to remove the halogen light from the analysis. So we have halogen light as lower rating, which we can remove. We can change the datum. Let's say the datum is CFL. So for the datum as CFL, this is the calculation. We can see that the halogen is getting higher negative value, and we can remove the halogen light from the competition, and then we can again using some refined competition methods, we can choose those alternatives. So this is how we have different alternatives from the brainstorming 65 method. We have design criteria from customer needs and stage 1. We use the method like Q selection to choose the better alternatives and remove the alternatives which are not performing well. Now we are at the third step of our process, which is to implement a concept. The implementation of concept can be done using various ways. One way is to concept embodiment, means the transformation of a product concept from the previous stage, which are feasible, and into physical systems. So transformation of product concepts into physical system. This is the main stage where the product design comes into a picture. There are various embodiment design methods, which includes physical and analytical modeling. We can have physical and analytical modeling, which we are discussing in detail in this course. So Professor Malki and Professor Naik are discussing this process using a FIM method, the modeling method. Design of manufacturing and assembly techniques are there, which makes product easier to produce. The faster manufacturing can be there, faster processes can be there, faster assembly can be there. Then another method is to design for environment and service, which will take care of the maintenance of the product, whether product can be easily maintained, product can be easily reused, product can be easily recycled. The product should be designed for the robustness. It should not deviate too much from its performance. It should perform to its mean performance. And another way is to study the failure modes and effect analysis, FME. So this is what the main objective of the course is there. I hope you will understand this part. And these are various techniques. We'll have a short look on the failure mode and effect analysis. What is failure mode and effect analysis? Failure mode and effect analysis help us to identify, define, and eliminate potential failure modes from a product system. Okay, so failure modes are ways by which our product can fail. these are different ways by which our product can fail. So we have to identify the failure modes and what are the effect of those failure modes, which will help us in making a product safer. So there can be different failure modes of a product. I have listed down some of the failure modes. Our product can fail by corrosion. Our product can fail by fracture. By if it is an electrical product, then the electrical short circuiting can be there, or there can be some open circuit, so that product will not work. Heat can be there, can be there, delamination can be there. So we have to first list all the probable failure modes of a product. So if we have a product, what are the possible failure modes of a product? And then we have to find the effect. So this is general FMEA analysis. First step is to identify all the failure modes. What are the various failure modes of the product? Then we consider any one of the potential failure mode and will identify the potential effect of a failure mode, that is done by severity. So this is effect severity. There is this index severity will denote by S. Okay, let's denote a product severity on the scale of 1 to 10. If the severity, the failure mode severity is not too much, it is safe to operate, then we'll give a low rating of 1. And if the failure can be very hazardous, it can take life of a person, then it can be given a higher rating of 10. If we have a moderate rating from 6 to 5, then customer will customer can bear with the failure mode and he is not bothered too much about the failure mode, then we will give a moderate rating of 3 and 5. So first we have to find the failure mode, and then we have to find the severity of the failure mode. What is the severity of the failure mode? And then we will have to provide ranking on the severity. The fourth step is to identify the potential cause of the failure mode. What is the potential cause? How can we how rapid it can occur? If a product is failing by corrosion, how fast it can corrode? Okay, so what is the chances that this failure mode will occur in this product? If the chances of occurrence are low, we'll provide a low rating for the occurrence. So this is another index occurrence. We denote it by O. If the failure mode occurrence is very low, then we'll give a low rating. If the failure mode occurrence is very high, we'll give it a high rating, or you can give any moderate rating also based on this field. Then we have to see how easy it is to detect the failure mode, whether the failure mode is difficult to detect or the failure mode is easy to detect. Like some of the failures we can see that the product will not work, it will stop. So the detectability index D will say that it is very easy to detect. We can see by naked eye, okay, this problem will occur. So when the product, the failure mode detectability is very easy, the ranking can be given as 1. And when it is very hard to detect, will give a higher ranking of 10. Meanwhile, we can give any ranking between them. So we have 3 ranks for the severity, occurrence, and detectability. We'll multiply all these ranks and we'll get a number which is called RPN number, risk priority number. If this risk priority number, it is greater than 100, then the product is risky. We have to eliminate the failure mode. If risk priority number is very high, like 500 or 1000, then this should be taken care immediately and it should be removed. The possible cause of this failure mode should be removed from the product, and then the product should be rechecked for the different failure modes. So this is how we'll have to identify an action for the improvement. If it is less than 100, RPM is less than 100, then there is not that much requirement to remove or to improve the product, and then we can either go for the documentation so that we know all the failure modes and we have taken care of the failure modes, or we can go for the remaining failure modes. So this is a systematic approach of FMEA analysis. This is a template of FMEA. We have to name a product or function. What are the possible failure modes? We have to write down the possible failure modes, possible effects, give severity number, occurrence number, detection number, then provide RPN, and based on that RPN, we can decide whether to improve the product or use the product in the current situation. So this is an example from the Kevin Otto book. So we have a front door, interior of the front door. The failure mode is the corrosion of the interior of the front door. So the severity number given for this is different part. The severity number is given 7. The occurrence is given 6. The detectability is given 7. And the RPN number we got by multiplying 7 by 6 by 7 is 294. So you can see this is a failure mode where RPN is greater than 100 or 200. This should be taken care, this should be taken care, this should be taken care, and this should be taken care. So there are different failure modes which should be taken care and removed from the product so that our product can work effectively. And these are the sources from which I have prepared the talk. The book from Kevin Otto is the main source, is a good book on the product design and the techniques in reverse engineering. So with this, I want to finish my presentation. If you have any questions, you can ask.
Thank you, Dr. Joshi, for your nicely timed lecture. Dear participants, if you have any questions, you can please ask the questions, 1 or 2 questions quickly now. It is close to 11 o'clock. Yes, please. Any question? I'll just check the chat box if there is any question.
Yeah. So,
No, sir, there is no question from the participants.
Good morning, sir.
okay.
Yeah.
Yes.
Sir, somebody is trying to talk?
Yes. Please go ahead.
Hello.
Yeah, please.
Yes.
Sir, one question from my side.
Yes,
Like reverse engineering, what is the status of a country in the field of reverse engineering? Like there are several products which are being exported from other countries, like Chinese product, which they are able to sell. If you take an example of a mobile, they are able to just sell at a very cheap rate. That technology. So why can't we go for reverse engineering, study that, and build that same product at lower price in a country so that we can even manufacture? So what is the status of reverse engineering in a country?
Okay, okay. Thank you, Sajjanji, for asking the question. So, the answer of the question lies in your question only. You told that the products which are mostly exported from, imported from the China and all. So, what the status is that you should know the technology which the other countries are using to uncover the product. Okay. The problem with these machines which we are importing from China, Taiwan, is that mm, they don't disclose their technology very much. The reverse engineering, it is very hard to reverse engineering their product. If we are using some IC, they will remove all the marking from the IC so that you cannot know what is the IC, what is the IC which they are using. If they are using some transformer, they will remove all the markings on the transformer. So it is very hard to gain information from those products. And to directly answer your question, the current state of reverse engineering in India is not that good. We are not able to do reverse the mechanical engineering to which India claims. Recent machines are just imported from foreign and just labeled Indian names and are sold. But we hope that in future will improve in this line also. So I hope you got your answer.
Okay, sir. Good reply you have given. Means they remove the specifications, so it's very difficult to get their design, isn't it? Okay,
Yeah,
okay, sir.
yeah.
Thank you very much, sir.
They are clever. They don't want their product to be reverse engineered. Okay. Thank you, Sachin.
Thank you, sir.
Yeah, so it is 11, already 11 o'clock, Dr. Joshi.
Thank you, Sachin sir, for inviting me for the time.
I just will sum up your session and then we will close. Give me a minute. Yeah, so it is already 11 o'clock. Let us actually wind up the session. I am personally on behalf of my institute and on behalf of AICT and my own personal behalf, I thank Dr. Joshi for giving such an informative lecture on product design process, which also includes the aspects of product design. He has very systematically, in academic manner, presented the topic in three phases. Namely, the understanding the opportunity, which was phase one, and then developing the concept or concept generation, which was primarily part of phase two, and implementation of the concept in phase three. The several techniques he very nicely explained in both the concept development and implementation phases of the product design. And he also has pinpointed the location where our finite elements and its associated applications are going to sit in the whole context. It was a very informative lecture, sir. I have been very carefully listening to it, and it was a good knowledge addition to all of us. I hope the participants also have the same feeling. Some of them have given their feedback also that it was a good lecture. So with these brief words from my side, I thank you for sparing your valuable time from your busy academic schedule. I know that academic schedule is going on everywhere in the country in all educational institutes. So I am thankful to you for giving sparing your valuable time and becoming part of this AICT sponsored faculty development program. Thank you very much.
Thank you, Sachin sir, for the kind words. And please provide the feedback from the participants with the area where we can improve in the content. So I would like to get the feedback from the participants. If you get any feedback in any constructive criticism, that will be uh, accepted.
Yes, sure, Dr. Joshi. Thank you very
Thank
much.
you, sir.
Bye. Good day.
Thank you, sir. Bye.
Dear participants, the time is already up. We are going to meet at 11:30 for the next session. You can take a break and join again at 11:30. Thank you.